right, so next we're going to relate how percentiles relate to the normal distribution. And just to give you a reminder, back in chapter 3, we talked about percentiles. So the kth percentile, so like the 10th percentile, for example, which you could denote p sub 10, or I've got here p sub k, means that k percent, or in this case 10% of the values, are less than or equal to the value of whatever the percentile is. So remember, if I said the 10th percentile for height of 13-year-old girls is 4 feet 10 inches, that would mean that all 14-year-old girls, 10% of 14-year-old girls are 4 feet 10 inches tall or less. Okay, so how does that then relate to the normal distribution? Well, it pretty much relates this way. So if here we have some sort of a normal distribution, and here in the middle is mu always, okay? Somewhere in there you have a p sub k. It doesn't have to necessarily be the one I would be talking about. And then if you highlight to the left, because it's the percentage of values that are less than or equal to, what that means is that in this region, k percent of the area happens to fall in that region. Okay, so the probability that x, whatever that is, the height of girls, for example, is less than or equal to p sub k, that percentile, okay, so 4 feet 10 inches is going to be equal to k percent. Okay. Again, not anything necessarily earth-shattering. We're just trying to take something we already knew and relate it to a new context of a normal curve. All right, so the next one, what is a standard normal distribution? Well, a standard normal distribution we've actually already learned about when we talked about z-scores, also back in chapter 3. Z-scores are normally distributed with a mean of 0 and a standard deviation of 1. Remember, the whole point of a z-score was to be able to let you compare two different things. Like we compared ACT performance to SAT performance, even though the point scales are completely and entirely different. We can remove the units and just scale it down to this z-score. So what that would look like in terms of a normal distribution, well, since the mean is 0, in other words, you scored on the mean, so you are 0 standard deviations above or below the average. What we do is we just label these as 1s and 2s and 3s for 1 standard deviation above, 2 standard deviations above, 3 standard deviations above the mean, or on the left side, -1, -2, and -3, meaning we are 1, 2, or 3 standard deviations below the mean. Again, nothing different from what we did back in chapter 3, just now applying it to a normal curve. So, how do z-scores relate to a standard normal distribution? Well, this is pretty straightforward, actually. The standard normal distribution the standard normal distribution is the distribution of z-scores. That's what it is, okay? So there is nothing special really about it other than, again, instead of saying you were 2 inches above the mean, you would say I was 0.234 standard deviations above the mean, or what have you. Okay. So a few other things here. What else can be said about normal distributions? Well, this is kind of a big one here, the empirical rule. Okay, the empirical rule says that about 68% of the data is within 1 standard deviation of the mean. So about 68% falls within 1 standard deviation to the right or the left of the mean. Okay. About 95% falls within 2 standard deviations of the mean, and 99.7% falls within 3 standard deviations of the mean. So you remember whenever we talked about being 2 standard deviations away was unusual, and we talked about that being less than 5%. Do you notice that 95% of the data within 2 standard deviations of the mean, that's leaving that 5% left over? to say it's unusual, there's a link there as well. Okay, there's a reason all that fits together. So a couple notes here before I draw you a picture of the empirical rule. So it is an approximation. Okay, it's only going to give you an idea of what the size of the probability is for different scenarios. It's an estimator, okay, but it's just that. It's an estimate. We will give some more specifics on that later. So what we're going to do here is on this next page, we're going to draw a normal curve that depicts the empirical rule. And I'm going to keep switching colors on you a lot in this particular instance to hopefully make this stand out a little bit. All right, so the first thing we need is we need our normal curve. So I'm just going to jot that in. Okay, with the mean here in the middle. And then again, we can keep marking the standard deviations. So this is 1 standard deviation, 2 standard deviations, 3 standard deviations above the mean. In fact, you know what? I'm going to make this, that mu, I'm going to make it a 0 just to make it a little easier to do. 1 standard deviation below, 2 standard deviations below, 3 standard deviations below the mean. Okay, first set of colors here. So it says 68% falls within 1 standard deviation of the mean. Remember, the mean is right here in the middle. Okay, so that means that in this section here that I am shading in, 68% of the data falls in that region. Okay, if I draw in the line here at 0, and this is 68% from the -1 to the 1, knowing this is symmetrical, that means that 34% falls 1 standard deviation below, and the other 34% falls 1 standard deviation above the mean, because again, remember, the distance or the area from there to there is 68%, and so we divide that up to the right and to the left of the mean. Okay. The next mark said that 95% of the data falls within 2 standard deviations of the mean. So now we're talking from here out to here. This is 95%. Okay. Well, if 68% of the area from the -2 to the 2 is already accounted for, that's the stuff that's already shaded in, then that means that this part here and this part here account for 95% minus 68%, which is 27% of the area in those 2 regions I just shaded. Now we have to split that 27% up between the right side and the left side, and so each of those regions contains about 13.5% of the data or the area. Okay, again, probability, area, the amount of data, all the same thing. Okay, moving beyond that. So within 3 standard deviations of the mean, so now we're talking almost the whole curve, 99.7% of the data falls in there. So again, shading in these spots here that I have left, okay, again, 99.7%. So 95% is in the -2 to +2 range. That leaves me with 4.7% left in those 2 regions I just drew. So that leaves me with let me make that a little darker if I can. There we go, 2.35%, 2.35% on each end. Okay, but we are not done yet, because we still have these regions. Let me grab another color here. We still have these regions out here, okay, beyond 3 standard deviations. And remember, the area under the curve totals 100%. We so far have only taken care of 99.7%. 99.7% taken away from 100% is 0.3% left over, which we then have to split up between the right and the left sides. Okay, so now if you add up all of those percentages under the curve, well, in my 2 I had to draw arrows for because they wouldn't fit, that will add up to 100% of the area under the curve. Again, this is an approximation. Okay, this is called the empirical rule, but that gives you kind of a rough idea of how likely or unlikely something is based on the number of standard deviations you are from the mean.